close your eyes, take a slow breath, and imagine, somewhere far beyond our sun, past the planets we know, there is a world unlike any we've ever set foot on. It is larger than Earth, heavier, older, a super-Earth. Here the ground pulls at you just a little more with every step. The mountains are taller, carved by winds that have blown for ages. The oceans are deeper, their waves heavy with the weight of gravity. The air is thick, carrying scents and sounds in ways that feel both familiar and strange. Tonight we'll journey there together. We will walk its forests, climb its vast ridges, and drift across its silver lakes. We'll feel the gentle weight of its skies pressing down, holding us close. There is no rush here. No noise, only the slow heartbeat of a world that has never known us yet seems to welcome us. So settle in, breathe deeply, and let's begin. Arrival on a super-Earth. You open your eyes to the sound of your own breathing inside the soft, steady rhythm of your suit's air supply. The cabin lights are dim, and beyond the small, rounded window of the spacecraft lies a vast, living world. This is not Earth. It's a planet larger, heavier, older, a super-Earth. From orbit, you can see the deep blues of its oceans, swirling white clouds that seem to stretch endlessly, and continents shaped in ways no cartographer from home could imagine. The horizon curves more gently here, a sign of its great size. It is familiar, but also impossibly alien. The ship descends slowly, gliding through the upper layers of the atmosphere. The colors outside shift. Blues deepen into sapphire, clouds glow with gold and silver edges as the sunlight bends differently through the thick air. Each breath you take feels heavier, almost richer, filled with an unseen weight. As the craft breaks through the final layer of cloud, the landscape unfolds. Mountains rise like jagged teeth, but taller, broader, and older than any on Earth. Their peaks are wrapped in wisps of fog, and their slopes are etched with winding rivers that glint in the light. Below, forests stretch for hundreds of miles, their canopy so dense it looks like a dark green sea frozen in place. You feel the first pull of the planet's gravity as the ship lands. Your limbs are heavier, the seat seems to hug you tighter. On Earth, standing up would be automatic. Here you'll need more effort. It's not painful, but it is undeniable. This world demands your strength. The landing hatch opens with a slow hiss. Warm, thick air brushes your skin as you take your first step down the ramp. Your boots sink slightly into the soil, which is darker and richer than anything you've known. Every sound seems muted. Your footsteps, the faint rustle of leaves, as if the dense air swallows noise before it can travel far. The sky above feels close even though it stretches endlessly. The higher pressure and thicker atmosphere bend the sunlight into subtle shades. Pale gold near the horizon, deep azure overhead. Every breath fills your lungs with a comforting heaviness, as though the air itself wants you to rest here. You look toward the distant mountains again. Even from miles away, they seem alive, as if the planet itself is aware of your arrival. Somewhere in those forests, life has evolved for millions of years under gravity's patient hand. adapting to this heavier, slower rhythm. And now, you are part of it. You take another step forward, leaving the spacecraft behind, and begin your journey into a world where every stone, every tree, and every gust of wind whispers, "This is not your home." But it could be. Stepping onto a new world, sir. The air feels different here. Not cold, not warm, just full. Each breath feels heavier, richer, as if every molecule carries more life within it. The colors around you are softer but deeper at the same time. The greens of the plants, the blues of the distant sky, the golden light that pours through thick clouds. You take your first step and gravity greets you. It's not crushing, but it's enough to remind you that you are somewhere else. Your body feels just a little heavier. Your feet sink more deeply into the soil, and every movement is a fraction slower than you expect. Yet there's a strange comfort in it, like the planet itself is holding you close. All around you, the land stretches into the horizon. Mountains rise higher than any on Earth, their peaks lost in layers of drifting mist. Valleys are carved into patterns so vast that rivers wind through them like silver threads. The sound of water is everywhere. Rushing streams, distant waterfalls, the steady rhythm of waves against unseen shores. The sky here is different too. The atmosphere is thicker, scattering the sunlight into a soft, hazy glow. Clouds are larger, slower, drifting lazily across the horizon. And through gaps in the mist, you can see a sun, perhaps larger, perhaps smaller than our own. But its light feels older, wiser. Somewhere nearby, a forest waits. Its trees are unlike anything on Earth. Taller, broader, their branches twisted into shapes sculpted by centuries of wind, leaves shimmer in a way that makes it hard to tell if it's the sunlight or something within them. As you walk toward it, you realize this is not just a new planet. It is a living world, ancient and patient, and you are only a guest. Living under a heavy sky. Above you stretches a sky unlike anything you have ever known. The air here is thick, not unpleasant but full, as if every breath carries more weight and substance. On this super Earth, the atmosphere is denser, its molecules packed more closely together. Each inhale feels rich and slow, as though you're drinking in the very essence of the planet itself. Your chest rises and falls with a gentle heaviness, reminding you with every breath that this is a place far from the delicate balance of Earth. Because the air is denser, sound carries differently here. A whisper doesn't vanish into the distance. It lingers, wrapping itself around you like a soft echo. A bird's call, if there are birds, would travel farther, clearer, and more resonant. The wind itself has a deeper voice, a low hum that you can almost feel as much as hear. The weight of the atmosphere also changes the very color of the sky. On Earth, light scatters through thinner air, painting the heavens in pale blue, but here sunlight filters through a far greater thickness, bending and scattering in ways that make the colors deeper, more vivid. At midday, the sky is not the bright pastel blue of home. It is a rich, sapphire ocean above your head, stretching endlessly. As the sun begins to sink, the world transforms into a canvas of molten golds, deep purples, and smoldering reds. These sunsets last longer, the thicker air slowing the fading light, letting you linger in that quiet in-between time. Looking up, clouds form differently too. They are larger, grander, their shapes more dramatic. The heavy air allows them to hold more moisture, and they move slowly like vast floating continents. In the early morning, the low-lying fog clings stubbornly to the hills, curling around valleys and forests, as if reluctant to let go. When rain comes, the droplets fall gently but with a satisfying weight, each one cool and refreshing against your skin. But life under a heavy sky is not without its challenges. The thicker atmosphere presses down on you constantly, and though it's subtle, you can feel it in your muscles, your movements just slightly slower, more deliberate. Climbing a hill leaves you more aware of your own breath. Yet over time, your body would adapt, muscles growing stronger, lungs learning to work with the denser air. And there is another gift the heavy sky brings: protection. This atmosphere shields the planet more effectively from space debris and harmful radiation. The stars above twinkle more softly, filtered by the thick air, making the night sky a little gentler on the eyes. In this world, even darkness feels padded and safe, as though the sky itself is wrapping you in a protective embrace. Living under such a sky would be an experience both humbling and awe-inspiring. Every breath, every sound, every sunset would remind you that this is a world shaped by gravity and air in perfect, heavy harmony. It is a place where the very atmosphere becomes part of life. Not just something you exist within, but something you can feel, taste, and carry inside you. Endless landscapes and the canvas of impossibility. Imagine standing on the surface of a super-Earth, looking out across a horizon that seems to stretch into infinity. You're not just seeing a bigger version of our world. You're witnessing landscapes that operate by entirely different rules of physics and scale. These aren't just larger planets. They're canvases for nature's most extreme artwork. Picture mountain ranges that make the Himalayas look like gentle hills. On a super-Earth twice our planet's size, peaks could soar 30, 40, even 50 kilometers into the sky. So tall they pierce through multiple layers of atmosphere, their summits existing in near-space conditions while their bases remain shrouded in thick, alien air. The gravitational forces shaping these worlds create geological drama on an unimaginable scale. Tectonic plates pushed by incredible internal pressures don't just shift. They collide with the force of cosmic catastrophes. Mountain-building events that take millions of years on Earth might happen in mere thousands on a super-Earth. Entire continents could rise from ocean floors in geological heartbeats. But it's the water that tells the most incredible story. Imagine oceans so vast and deep they contain more water than exists in our entire solar system. These super oceans could plunge 100 kilometers down, depths so crushing that water itself begins to behave like liquid metal. At these depths, the pressure creates phases of ice that remain solid at temperatures hot enough to melt copper. Rivers on these worlds don't just flow. They become geological forces of destruction and creation. With gravity pulling water downward with tremendous power, these waterways carve canyons that dwarf anything on Earth. Picture the Grand Canyon, then multiply its depth by 10, its width by 20. These aren't just geographical features. They're scars across continents, visible from space as great wounds in the planetary surface. The weather systems defy comprehension. Storm fronts could span entire continents, with hurricane systems so massive they develop their own weather patterns within them. Lightning storms might rage for decades, their electrical displays visible from neighboring moons. Rain doesn't just fall, it crashes down with the weight of gravity that could flatten structures built for Earth's gentle precipitation. And here's what makes it truly extraordinary: the diversity. A single super-Earth could contain more varied landscapes than our entire solar system. Polar ice caps the size of continents. Desert systems that make the Sahara seem like a sandbox. Forest ecosystems so dense and towering they create their own atmospheric layers. These endless landscapes aren't just backdrops. They're the stage upon which the greatest drama in the universe might unfold, the emergence and evolution of life itself. Every mountain peak, every ocean trench, every storm system becomes a potential cradle for biology we can't even imagine. This is the world-building power of super-Earths. Not just bigger planets, but entirely new categories of worlds where the impossible becomes inevitable. The Green Revolution: how life finds a way. From our exploration of super-Earth's endless landscapes, we now step into perhaps the most fascinating chapter of all: how life adapts to these alien worlds. And nowhere is this adaptation more extraordinary than in the plant kingdom. The green architects that transform barren rock into living, breathing ecosystems. Picture yourself walking through a forest on a super-Earth, and immediately you'd notice something profoundly different. These aren't just bigger versions of earthly trees. They're evolutionary masterpieces sculpted by forces our planet has never known. Under the crushing weight of higher gravity, plants have had to completely reimagine how they reach for the sky. On Earth, our tallest trees struggle to pump water more than 100 meters upward. That's the absolute limit of what capillary action can achieve. But on a super-Earth, this fundamental constraint becomes a death sentence for any plant trying to grow tall the traditional way. So evolution does what it does best. It finds impossible solutions to impossible problems. Enter the floating forests. Imagine trees that don't fight gravity, but embrace it as a partner. These Zeppelin plants have evolved to release hydrogen from their photosynthesis directly into inflatable bladders, turning themselves into living balloons anchored to the ground by massive root systems. Picture walking through a grove where giant tree canopies hover 50 meters above you, connected to Earth by vine-like tethers thick as telephone poles. But that's just one solution. Other plants have developed active pumping systems, biological hearts built into their trunks that literally beat to push water upward. You might hear these forests before you see them, filled with the rhythmic pulsing of 1,000,000 tree hearts working in perfect synchronization, creating a planetary heartbeat that echoes across continents. The flowers tell an even more incredible story. Under intense gravitational pressure and potentially different stellar radiation, blooms on super-Earths have evolved colors we don't even have names for. Some flowers growing under the light of cooler, redder stars appear almost black to conserve every photon of energy. Others, bathed in the blue-white light of hotter stars, shimmer with reflective petals that look like living mirrors, deflecting excess radiation while still capturing what they need. And then there's the grass, But calling it grass hardly does it justice. On worlds where gravity can be twice Earth's strength, ground-covering plants have evolved into living carpets of incredible density. Individual grass blades might be shorter, but they're so tightly packed they form almost impenetrable mats. Walking across a super-Earth meadow would feel like crossing a trampoline made of emerald springs. The most mind-bending adaptation involves the mega-organism, single plants that span hundreds of kilometers. Imagine forests that look like millions of individual trees but are actually one colossal organism, connected by underground networks so vast they function like planetary nervous systems. These superplants coordinate weather patterns, direct nutrients across continents, and essentially become living landscapes that blur the line between individual organism and ecosystem. The reproductive strategies defy everything we know about plant biology. Some super-Earth flowers have evolved to use the planet's intense gravitational fields as launching mechanisms, literally catapulting their seeds across continents with spring-loaded mechanisms that would make human engineers weep with envy. Others have developed relationships with the planet's extreme weather systems, timing their reproduction to coincide with the massive storms that rage for decades, using hurricane-force winds as their distribution network. Perhaps most remarkably, these plants haven't just adapted to their worlds. They've begun to reshape them. The floating forests create their own microclimates, their elevated canopies forming cloud layers that influence weather patterns below. The mega-organisms actively modify soil chemistry across entire continents, creating nutrient gradients that support biodiversity on scales that make Earth's Amazon rainforest look like a small garden. This is evolution unleashed from Earth's constraints. Plant life that has had billions of years to experiment with solutions our world never needed. Every leaf, every flower, every blade of grass represents a masterpiece of biological engineering, proving that life doesn't just survive in impossible conditions. It thrives. It innovates, and it transforms entire worlds into living artwork painted in shades of green we're only beginning to imagine. Animals that defied gravity's tyranny. From the extraordinary adaptations of plant life we now enter the realm of creatures that call these heavy worlds home. Picture yourself as an explorer stepping into a super-Earth ecosystem for the first time, and immediately you realize you're witnessing evolution's most extreme experiment. Animals that have spent millions of years locked in an epic battle against forces that would crush any Earth creature in seconds. On these worlds where gravity can be twice, 3 times, even 10 times stronger than home, every animal you encounter represents a masterpiece of biological engineering that challenges everything we thought we knew about life itself. Let's start with the most obvious adaptation: size. Forget everything you know about large animals. On super-Earths, the age of giants has ended before it could begin. Under crushing gravitational forces, evolution has favored the compact, the sturdy, and the impossibly dense. Imagine creatures that look like living tanks. Broad, low to the ground, with legs thick as tree trunks and bones that are essentially biological steel. These aren't just smaller versions of Earth animals. They're completely reimagined life forms. Picture a creature with the mass of an Earth elephant, but compressed into a body barely a meter tall. Its legs aren't just thicker. They're architectural marvels with bones that have evolved to be hollow yet stronger than our densest materials. But here's where it gets truly extraordinary: the cardiovascular adaptations. On a world where gravity ruthlessly pulls blood downward, hearts have become engines of incredible power. Some creatures have evolved multiple hearts positioned at strategic points throughout their bodies like biological pumping stations. Others have developed pressure gradient circulation, blood vessels that actually use the planet's intense gravity as part of their circulatory system. The most remarkable adaptations involve movement itself. Traditional running becomes nearly impossible when your body weight is multiplied by factors of 3 or more. So evolution has crafted solutions that seem pulled from science fiction. Some creatures have developed rolling locomotion. They literally ball up and use gravity to their advantage, racing down slopes like living boulders, then using spring-loaded mechanisms to launch themselves uphill. Others have mastered gravity surfing. Picture lizard-like creatures with wing membranes that don't fight gravity but work with it, using the planet's intense pull to generate incredible speeds in controlled falls, then using built-in air bladders for course correction. Perhaps most mind-bending are the burrowing specialists, creatures that have turned the heavy world's disadvantage into their greatest strength. With gravity providing enormous compressive force, these animals can dig through seeded rock as easily as earth moles dig through soil. Their bodies are living drilling machines with diamond-hard claws and reinforced skulls. The predator-prey dynamics tell perhaps the most fascinating story of all. With traditional chase scenes impossible under crushing gravity, evolution has favored ambush specialists and creatures with explosive, short-burst capabilities. Imagine predators that compress their entire hunting strategy into single, devastating lunges. Creatures that can store energy for days, then release it in one gravity-assisted strike. Their prey have developed armor that makes Earth's most heavily defended animals look fragile. Some herbivores have evolved shells thick as bunker walls with internal structures that can lock into defensive positions, turning the animal into an immovable fortress. The flying creatures defy every principle of aerodynamics we understand. Traditional wings simply cannot generate enough lift to overcome the crushing pull of a super-Earth. So evolution has invented alternatives that border on the magical. Some have developed internal helium production. They're living balloons that achieve buoyancy through biological chemistry. Others use rapid wing-beating frequencies powered by hyper-efficient muscle systems. Social structures have evolved around gravity's demands. Creatures that would be solitary on Earth form complex support networks, literally supporting each other's weight during vulnerable moments. Reproduction strategies involve entire communities helping to support pregnant individuals against gravity's crushing pull. These aren't just animals adapted to heavy worlds. They're living proof that life doesn't just survive impossible conditions, it transforms them into opportunities. Every creature on a super-Earth represents millions of years of evolution pushing against the fundamental forces of the universe. And winning, not by conquering gravity, but by making it their partner in the endless dance of survival. Cities built to defy the crushing sky. From the remarkable creatures that have adapted to these heavy worlds, we now turn to perhaps the most ambitious chapter of all. How humanity might one day build civilizations on super-Earths. Picture yourself as a colonial architect tasked with designing the first human city on a world where gravity could crush traditional buildings like paper houses in a hurricane. This isn't just about making structures bigger or stronger. On a super-Earth, every principle of architecture, urban planning, and transportation must be completely reimagined. These aren't just heavier versions of Earth cities. They're entirely new forms of human habitation that push the boundaries of engineering and imagination. Let's start with the most fundamental challenge. How do you build up when gravity is constantly trying to pull everything down with crushing force? Traditional skyscrapers become death traps on worlds where structural load multiplies by factors of 3, 5, or even 10. So human engineers would turn to nature's own solutions, the same principles that allowed super-Earth's plants and animals to thrive. Enter the age of dome cities and pyramid settlements. These aren't just aesthetic choices. They're survival strategies written in steel and concrete. Dome structures distribute gravitational stress evenly across their surfaces, while pyramids channel the crushing weight directly into their foundations, creating cities that work with gravity rather than fighting against it. But here's where it gets truly revolutionary. Underground expansion. On super-Earths, building down becomes far more practical than building up. Imagine vast subterranean metropolises carved directly into the planet's crust, where intense gravity actually helps compress and strengthen tunnel walls. These underground cities could span hundreds of kilometers, with transportation networks that use gravity trains, vehicles that literally fall through tubes to reach incredible speeds. Surface architecture tells an equally fascinating story. Buildings would be broad and low, spreading out like living pancakes rather than reaching skyward. Imagine residential blocks only 3 or 4 stories tall, but stretching for kilometers, connected by covered walkways that protect inhabitants from the planet's intense weather systems. Transportation becomes a masterpiece of creative engineering. Forget cars as we know them. On a super-Earth, wheeled vehicles would need to be built like tanks, just to support their own weight. Instead, human settlements might rely on maglev trains that hover just above the ground, or transportation tubes where people travel in pressurized capsules, using gravity itself as propulsion. The most ambitious settlements might embrace floating cities, using the planet's dense atmosphere to their advantage. These aerial habitats could hover thousands of meters above the crushing surface gravity, connected to the ground by massive tethers or elevator systems. Picture residential rings that rotate to create artificial gravity gradients, allowing inhabitants to experience different gravitational zones. Road systems would be unlike anything on Earth. Instead of fighting gravity with complex overpasses, super-Earth cities might use natural slopes and gravity-assisted highways. Transportation networks would follow the planet's contours, with vehicles that harness gravitational potential energy for efficient travel. Perhaps most remarkably, these settlements wouldn't just survive on super-Earths. They would thrive by creating entirely new forms of human community. The shared challenge of living under crushing gravity would foster unprecedented cooperation. Building maintenance, transportation, and daily activities would require community coordination on a scale never seen on Earth. These aren't just human settlements adapted to heavy worlds. They represent humanity's greatest architectural triumph. Every dome, every underground tunnel, every floating habitat would be a testament to human ingenuity, turning the universe's most crushing challenges into opportunities for civilization unlike anything Earth has ever seen. On super-Earths, humanity wouldn't just build cities. They would create entirely new ways of living that transform limitation into liberation, proving that even under impossible worlds, human creativity finds a way to flourish in ways more beautiful than we've ever imagined. Feeding humanity under the crushing sky. From the magnificent cities humanity would build, we now turn to the most fundamental challenge: feeding civilization on a world determined to crush every living thing beneath its relentless gravitational pull. Picture yourself as a colonial farmer on a super-Earth surface. You sink deeper with each step, tools feel impossibly heavy, and every traditional farming method becomes useless under gravity 3 times Earth normal. This isn't about growing bigger plants. On super-Earths, agriculture becomes complete reinvention. Every seed, every crop, every technique must be redesigned from the ground up. Traditional crops cannot survive. Wheat stalks would collapse under their weight. Corn would buckle and break. Even potatoes would struggle as stems cannot support gravitational loads. So what grows on super-Earths? Enter radical crop engineering. Imagine fields of dense, low-growing grains that spread horizontally like living carpets rather than reaching skyward. These gravity grains might produce seeds so nutrient-packed that handfuls could feed people for days. Root vegetables become heroes of super-Earth agriculture. With intense gravity compacting soil and driving nutrients deeper, these worlds would produce tubers of incredible density. Picture carrots the size of tree trunks, potatoes with nutrition of multiple Earth potatoes compressed into compact packages. But here's where it gets revolutionary. Hydroponic systems. In controlled environments where gravity can be partially negated through water buoyancy, Earth crops might thrive. Imagine vast greenhouse complexes where plants float in nutrient solutions, supported by liquid rather than fighting crushing forces. Farming equipment tells its own story. Traditional tractors become impossible. They would sink like stones. Instead, farmers might use distributed micro-robots working like mechanical ants, each light enough to move while collectively accomplishing massive tasks. Most fascinating are entirely new crops evolving for super-Earth conditions. Scientists might develop mushroom-like organisms thriving under pressure, creating vast underground fungal farms that turn crushing gravity into advantage. These pressure-grown foods could be incredibly nutritious, packed with concentrated proteins. The most ambitious projects might involve floating farms, aerial platforms hovering in dense atmosphere using reduced gravity at altitude to grow traditional crops. These sky gardens could connect to settlements, creating three-dimensional farming ecosystems. Perhaps most remarkably, these challenges would drive humanity to create entirely new relationships with food production. Communities might develop around underground growing systems, with neighborhoods built around fungal farms. Shared challenges would create agricultural cooperatives unlike anything on Earth. These aren't just adapted farming techniques. They represent humanity's most creative response to universal challenges. Every new crop, every innovative method would prove that human ingenuity can turn crushing obstacles into opportunities. On super-Earths, humanity wouldn't just grow food, they would revolutionize agriculture itself, creating systems so efficient that these heavy worlds might feed more people per square kilometer than Earth ever could, turning gravitational disadvantage into triumph. When weather becomes warfare. From the revolutionary agriculture feeding super-Earth colonies, we now turn to perhaps the most spectacular and terrifying aspect of these worlds, their weather systems. Picture yourself standing in the first human settlement on a super-Earth, watching the horizon darken as something approaches that makes Earth's most powerful hurricanes look like gentle summer breezes. On these heavy worlds, weather isn't just meteorology. It's planetary-scale warfare between forces that dwarf anything our home planet has ever experienced. The same crushing gravity that shapes every aspect of life also creates atmospheric conditions so extreme they redefine what we mean by storms, winds, and seasons. Let's start with atmospheric pressure. On a super-Earth, the sheer weight of atmosphere creates surface pressures that could be 10, 20, even 50 times greater than Earth normal. This isn't just denser air, since it's an entirely different medium where weather patterns operate by completely alien rules. Imagine storms where atmospheric pressure alone could crush unprotected structures. Rain doesn't just fall, it plummets with the force of liquid bullets, driven by gravity so intense that each droplet hits the ground with devastating impact. A gentle drizzle on a super-Earth could shatter windows, while moderate rainfall becomes bombardment that forces entire cities underground. The scale of these weather systems defies comprehension. On worlds twice Earth's size, storm fronts don't just cross regions, they engulf entire hemispheres. Picture hurricanes with eye walls larger than Earth's entire circumference, spinning for decades across ocean systems that make our Pacific look like a small lake. Temperature variations tell an equally incredible story. NASA's observations reveal super-Earths experiencing thermal swings of over 2,300 degrees Fahrenheit from one side to the other. Imagine weather systems where seasonal change isn't measured in degrees but in thousands of degrees. Zones where molten rock rain could fall during summer, followed by winters cold enough to freeze nitrogen. Wind patterns defy every principle of meteorology we understand. Under intense gravitational forces, surface winds might regularly exceed 500 kilometers per hour, with gusts that could literally move mountains by carrying away loose rock and soil. These aren't just stronger breezes. They're atmospheric rivers moving with the force of liquid tsunamis. Lightning takes on entirely new meaning in these dense atmospheres, with atmospheric pressure creating conditions where electrical discharge can arc across vast distances. Super-Earth lightning storms might generate bolts kilometers wide, carrying electrical energy that could power entire Earth cities. The thunder would be seismic shock waves, literally shaking the ground with each discharge. For human settlers, weather prediction becomes life and death when storms can generate pressures that crush buildings or winds that carry away entire settlements. Underground cities aren't architectural preferences. They become absolute necessities for surviving weather systems that treat surface structures like leaves in a hurricane. But perhaps most fascinating is how these extreme weather patterns might create opportunities. The massive atmospheric pressures could be harnessed for power generation. Storm systems that rage for decades could provide consistent wind energy. On these worlds, weather becomes the ultimate test of human engineering, creating conditions so extreme that survival requires complete rethinking of how civilization interacts with the forces of nature itself. Technology born from crushing necessity. From the extreme weather systems that shape daily survival, we now explore perhaps the most fascinating aspect of super-Earth civilizations. The revolutionary technologies that emerge when crushing gravity forces humanity to completely reimagine science, space travel, and energy systems. Picture the first human scientists on a super Earth, staring up at a sky that seems impossibly distant. On Earth, escaping gravity requires rockets burning massive amounts of fuel to reach orbit. But on a world where gravity could be 3 times stronger, traditional chemical rockets become virtually useless. The rocket equation becomes humanity's greatest enemy. You need exponentially more fuel just to carry the fuel needed for escape. So how does a super-Earth civilization reach space? Enter radical propulsion technologies born from desperate necessity. Nuclear pulse propulsion. Spacecraft pushed by controlled atomic explosions becomes not just theoretical but essential. Imagine ships that literally ride shock waves from nuclear detonations, the only force powerful enough to escape a heavy world's gravitational prison. But perhaps more revolutionary are the orbital launch systems that bypass rockets entirely. Picture massive electromagnetic railguns stretching across continents, using the planet's crushing gravity to help compress and accelerate launch vehicles to incredible speeds. These aren't just bigger versions of Earth technology. They're completely new categories of engineering that turn gravitational disadvantage into mechanical advantage. Energy production on super-Earths tells an equally extraordinary story. The intense atmospheric pressures create opportunities for power generation impossible on Earth. Imagine pressure differential engines that use the massive atmospheric gradients to generate electricity, or geothermal systems that tap into planetary heat sources compressed by crushing gravitational forces. The most ambitious super-Earth civilizations might develop something unprecedented. Gravity-assisted manufacturing, using the planet's intense gravitational field to compress materials into forms and densities impossible to achieve on Earth. Imagine creating supermaterials by literally using the planet's weight as a cosmic forge, producing substances with properties that make Earth's strongest alloys look fragile. Space travel from super-Earths requires thinking beyond traditional concepts. Instead of fighting gravity, advanced civilizations learn to use it. Gravity slingshot systems become planetary catapults, using the world's massive gravitational field to accelerate spacecraft to velocities that would require enormous energy expenditure on lighter worlds. Perhaps most remarkably, the extreme challenges of super-Earth living drive rapid advancement in artificial intelligence and automation. When every physical task requires overcoming crushing gravitational forces, robots and AI systems become not luxuries, but absolute necessities for survival. These civilizations might develop AI centuries ahead of what Earth-based humanity could achieve. The ultimate breakthrough comes with the development of antimatter propulsion, the only energy source powerful enough to make interstellar travel practical from heavy worlds. While Earth civilizations might take millennia to develop such technology, super-Earth societies could be forced to innovate these solutions within centuries, driven by the absolute necessity of escaping their gravitational prison. These aren't just technologies adapted to heavy worlds. They represent humanity's greatest technological leap. Every innovation, every engineering breakthrough becomes proof that the universe's most crushing challenges can become the greatest catalysts for advancement, transforming limitation into the foundation for technologies beyond our wildest imagination. A day under the crushing sky. From the revolutionary technologies born from crushing necessity, we now explore the most intimate aspect of super-Earth existence. What does a single day look like for a human living under gravity that could crush an Earth-born visitor in seconds? Picture waking up in your underground habitat as artificial dawn lights gradually brighten. Your bed isn't just furniture. It's a medical necessity, designed with pressure distribution systems that prevent your body from being crushed during 8 hours of unconsciousness. Standing up requires the same effort an Earth human would need to lift a heavy backpack. Morning routines become exercises in careful engineering. Brushing your teeth with toothpaste that feels like liquid concrete. Taking a shower where water droplets hit with the force of small hammers. Getting dressed in clothing reinforced with support structures that help your body maintain posture against relentless gravitational pull. Your commute to work happens through underground tunnels or pressure-assisted transport tubes. Walking any significant distance on the surface would exhaust even the strongest human within minutes. Every step sinks deeper into soil compressed by atmospheric pressure that makes concrete seem soft. Work itself transforms into collaborative necessity. Tasks that one person could handle on Earth require teams on super-Earths. Moving equipment, operating machinery, even simple office work becomes community efforts. As humans support each other against the crushing environment, meals consist of incredibly nutrient-dense foods. A few bites providing energy that would require full Earth meals to match. Cooking uses pressure-assisted methods that create flavors and textures impossible under gentler gravity. Evening entertainment happens in specially designed low-gravity recreation centers, enclosed spaces where water buoyancy or magnetic systems provide brief relief from the crushing forces. These become precious sanctuaries where humans can move with something approaching Earth-normal freedom. Sleep preparation involves medical checks to ensure your cardiovascular system can handle another night under crushing pressure. Your home isn't just shelter. It's life support equipment that keeps you alive in an environment that treats human bodies like fragile glass under a hydraulic press. This is daily life where every breath, every movement, every moment becomes a testament to human adaptability and the extraordinary lengths civilization will go to survive in the universe's most challenging environments. When darkness brings peace. From exhausting days under crushing gravity, we turn to the most beautiful aspect, the night sky offering solace to impossible civilizations. Dense atmosphere transforms sunset into spectacular light shows. Colors we don't have names for paint skies as starlight filters through layers thick enough to bend light impossibly. Through atmosphere acting like natural telescopes, distant stars appear brighter than Earth's. Constellations seem touchable, concentrated by the same crushing air, making daytime survival difficult. Multiple moons create true magic. Super-Earths capture several lunar bodies, 2, 3, 5 moons dancing in different phases, their combined pull reshaping coastlines real-time. For humans fighting crushing gravity daily, nighttime becomes sanctuary. Underground cities connect to observation decks where families watch celestial shows above. As heavy worlds rotate into darkness, buried cities glow like jewels, revealing communities learning not just survival, but finding beauty in universe's most challenging environments. This is how days end, humans finding peace in impossible beauty above, gathering strength for another day, defying gravity itself. The dream of distant worlds. As our journey through these impossible worlds draws to a close, let yourself drift into the quiet contemplation of what we've discovered together. Picture yourself floating weightlessly in the observation deck of humanity's first super-Earth colony, watching multiple moons rise through dense atmosphere that turns starlight into living art. The crushing gravity that defined every moment of our exploration now feels distant, replaced by the gentle rhythm of artificial life support and the soft glow of bioluminescent plants adapted to alien soil. Close your eyes and imagine the whisper of pressure-assisted wind through underground cities carved from living rock. The sound of children's laughter echoing through corridors where humanity learned to thrive under impossible conditions. The gentle hum of gravity trains carrying dreamers between floating gardens and subterranean farms. These worlds we've explored together exist somewhere in the vast cosmos waiting. Planets where evolution has written stories in languages we're only beginning to understand. Where creatures roll like living boulders down mountainsides larger than continents. Where trees float like green balloons anchored to Earth by cables thick as buildings. In the gentle darkness of space between stars, super-Earths spin silently through their ancient orbits, their surfaces painted with auroras from multiple moons, their underground rivers carving canyons deeper than Earth's oceans. Worlds where weather systems rage for centuries, where the weight of atmosphere creates pressures that forge diamonds from morning dew. Perhaps someday human feet will sink into the dense soil of these heavy worlds. Perhaps children will grow up watching 5 moons dance across alien skies, learning to navigate by constellations that seem close enough to pluck like flowers from a cosmic garden. Until then, we carry these visions with us. Dreams of worlds where gravity teaches life new ways to dance, where impossibility becomes the canvas for nature's greatest masterpieces, where humanity might one day prove that even the universe's most crushing challenges can become home. Rest now in the knowledge that somewhere among distant stars, super-Earths wait patiently for the day when dreams become footsteps, when imagination becomes exploration, when the impossible becomes inevitable. Sweet dreams of heavy worlds and floating cities of creatures that surf gravity itself, and of the endless creativity creativity that blooms wherever life finds a way to call the impossible home. Thank you for joining our incredible journey through Super Earths. We've explored impossible worlds where gravity creates nature's greatest masterpieces. If you enjoyed discovering how life thrives in crushing conditions, please subscribe for more cosmic adventures. Like this video and comment which Super Earth adaptation amazed you most.